In this lesson video, we'll be looking at chemistry 1502. The topic for today is reactions of alcohol. We'll be looking at a specific reaction, which is dehydration of alcohols. Lesson 101, let us start. You should know that reactions of alcohol are useful in organic chemistry, and we have a number of reactions. So for the lesson series of reactions of alcohol, we will be using different types of labeling these lessons. So it simply means that for lesson 101.1 is the continuation of dehydration. If it happens that we go to lesson 102, you should know that it's another type of a reaction. Lesson 102.1, 102.2 is a continuation of that specific lesson that deals with that particular reaction. So in this lesson, we'll be dealing with the dehydration. The next lesson video, which is lesson 102, will be looking at oxidation. We also have the reaction of alcohol, which is substitution and reduction, esterification. We have different types of reactions that we'll be dealing with. So like I said, in this lesson video, we'll be looking at dehydration. So the basics that you need to know is that by now you know what is an alcohol. It's a compound that has an hydroxy group, which is OH, within the compound, and it is attached to the parent chain. So when we have an alcohol, let us say we have this particular alcohol, which is primary in this case. Doesn't matter whether it is secondary or tertiary. If you have an alcohol and then it undergoes dehydration, you should know that it will yield an alkene. So alcohols are pretty much interesting because we can involve them in reactions to form another functional group. Alkene, it's those compounds which has a double bond between carbon and carbon. If you can remember the first few functional groups we've looked at, it's alkanes, alkenes, and alkynes. Then alkenes are those compounds with a double bond. So alcohols undergo dehydration to form alkenes. That is the basic concept or basic principle about dehydrations of alcohols. Before we look at the first general example, to explain this reaction in detail, you should know that dehydration requires an acidic catalyst to protonate the hydroxy group. Sometimes instead of dehydration, you might hear the word acid-catalyzed dehydration of an alcohol. That is the reaction whereby you convert alcohol into alkenes. So we are going to look at steps as usual to explain this mechanism in detail. Let us take ethanol as our first general example. If you can check most of the organic chemistry textbooks, they've used this as the first general example. This is an alcohol because we can see we have an hydroxy group here, but I've just showed the bond between hydrogen and oxygen and also the lone pairs of oxygen. So the first step is the protonation, whereby you convert the hydroxy group into a leaving group. If you are familiar to the SN1 and SN2 nucleophilic substitution reaction, then you'd know how the leaving group behaves when it leaves the substrate. So what we do now, we cannot just remove this cannot just leave, but we have to convert it to a good leaving group so that it can leave this substrate or this compound. And in order to do that, we protonate, we use protons. In this case, you're going to use H+, but most of the time, the proton that we use to protonate this is H+. Sometimes you will see that it's written as H2SO4. You should know that the proton will come from this, meaning that if we remove or we extract one proton of hydrogen, one hydrogen proton, and then we'll be left with HSO4 minus, and then this is the one that will protonate this to be converted to a good living group. So in this case, for the general reaction, let us take it as our proton the way it is. So what actually happens is that this lone pairs will actually attract this proton, and then we should understand that when we look at the basics of Lewis diagram, suppose we have water molecule. We know the nature of oxygen. It is divalence. It simply means that it bonds 2 times. Should it happen that it bonds 3 times, you should know that it's going to have 2 lone pairs and a positive charge. And then the very same water molecule, if it bonds only once, it's going to have 6 lone pairs with a negative charge. And by the way, we can see that this is our hydroxide ion. So once this pair of electrons attract this proton, we are going to have oxygen, which it is bonded 2 times, then with lone pairs, and then it will have a positive charge. Sometimes this mechanism might be difficult because you do not understand the basics. So the first thing that happens is that this pair of electrons will be attracted by this proton to form this. This is no longer a hydroxy group, but we can clearly see that it is H2O. Step number 2. Water will leave the substrate to form a carbocation ion. If you are familiar to SN1 reaction, you'd know what I'm talking about. So homolytic reaction will occur here. This bonding pair will leave with the H2. Simply means that we are going to have a substrate with a carbocation ion, remember that water is no longer there. It is left with a pair of electrons. Then let us go back to Lewis again. We know that carbon is a tetravalence, meaning that it bonds 4 times. Let us simply put R. R simply represents any element that we might have as our terminal atoms here. If it bonds 3 times, you should know that it will have a positive charge. You can support this using the calculations of formal charges. So in this case, our carbocation ion will have a positive charge. And then having our water, because remember that if this pair of electrons leaves with this, by the way, this is a good living group. That is why we have to convert it first to be water so that it can be a good living group. So we have H2O, which will be like this. these two lone pairs are the ones which left. So this is basically H2O. Step number 3 is when we have to lose a proton that will give us an alkene. So remember that we need a double bond here. In this case, you can see that we have our carbocation here, which is this one. Then if we can lose this hydrogen, we'll be able to form a double bond here. So how do we do that? Water molecule will actually attract this proton, and then it will form, because immediately when this proton is lost due to this, it will actually leave and remember, it doesn't leave with this pair of electrons. We are going to have this, and then this pair of electrons will come here. So actually this step is whereby it loses this proton. At the same time, there is a formation of a double bond here, meaning that on the product we are going to have and then we have our double bond here, plus if this hydrogen joins this, we are going to have H3O plus. Remember that if oxygen bonds 3 times, it will have a positive charge. So the mechanism is complete, and you can see that this is an alkene. Let us quickly look at the next example. Let us look at the dehydration of butyl alcohol. Butyl alcohol, it's like this. Let me actually write it so that you can see the lone pairs. So the condition is heat. We know very well that a proton will be transferred to butyl alcohol from one of the protons of sulfuric acid, leaving HSO4 minus. And then we know very well that a good leaving group will be formed. So we have CH3, and then here we have, it will have a positive charge. And then from here we know that the leaving group will actually leave with a pair of electrons. And then we are going to have a carbocation being formed, and we are going to have our water molecule here. And then from here we'll have to look at the loss of proton, meaning that the third butyl cation will have to actually write it in detail. So let us just write this one like this, and then the rest we can just leave it in a condensed form. Well, it doesn't matter which one you do this, whether you do this one like this, it's still fine. the answer will still be the same, so that we can show the loss of proton. In this case, we have water, and then at the same time this bond will actually come here. Or just to make things understandable and neat, this plus is between this and this. You should understand that it is not an ion. So in this case, it will attack this proton. At the same time, this double bond will come here. Then we are going to have this is no longer here, and this bond is no longer here, but it is actually here. So we have a double bond here. We can just write it in condensed, but let us write it like this. Then we have this carbon and plus H3O. It's going to have a positive charge. So you can see that this is actually an alkene. In the next lesson video, which will look at more examples, and you'll have to know the hydride shift and also the methyl shift, which is very important in order to form a stable alkene, whereby there is a reaction whereby we have two products and one of them will be major, the other one will be minor, and we'll be looking at the concepts in which it makes it major and minor. That's it for this lesson video. This is Swahula SJ. Thank you very much.